Welcome to Carlton's Math Corner. Today we're going to continue our study on algebraic equations and functions. At this time, please make sure that you have your vocabulary packet out as well as your math journal. Today, we're going to be writing two variable equations to represent functions. And so basically, the equation that we're going to create is going to look similar to what we were looking at on our video 2 days ago. So we were creating function rules, and so this is what a function looks like, or an equation for a function with two variables. So the y stands for all the output, like the numbers that are coming out. That's called our range. And the x stands for all the numbers we're plugging in, the input, or we call it the domain. And so if I plug in the number 1, I can take 7 times 1 and I get the answer of 7. Now today, we're going to look at like tables like this, and we're going to try to figure out what is the pattern so that we can create kind of like a function rule. And we're going to create an equation that uses two variables, one for the input and one for the output. Okay, so we're going to start off looking at this table and looking at the data. And here's what I notice. I notice that over here in the output, I notice that there is a pattern between those numbers. I notice that they go up by 2s. So I can add 2 to 6 and I get to 8. 8 plus 2 is 10, and 10 plus 2 is 12. And so I notice that the pattern is increasing the same amount. And so what I know is that from last time, we learned that when amount increases by the same amount, or the same, like if there's a pattern on the side, that pattern is because of this number that's in front of the x. And so this 7 should match the pattern that is seen over here in the output category. And it does. These numbers go up by 7, and so there's a 7 in front of the x. So what I'm going to try is using the 2 that all of them are increasing by, and I am going to try to see if that works with this pattern. And so what I'm going to do is I'm going to say I'm going to multiply each number by 2, and so I'm going to say 2 times, and I'm going to plug in this number, which the first number is 2, and I'm going to ask myself, is 2 times 2, does that equal 6? Well, no, it doesn't. So I need to figure out what other operation could I do in this problem to get to the 6? Because right now I have 4. So what else would I need to do in order to get to 6? Correct, I would have to add 2. Well, let's see if that works for every single problem. So I'm going to take 2 times, and the number I'm plugging in now is 3. And then I'm going to add 2 to see if that works and gets 8. 2 times 3 plus 2, yes, it works, it's 8. So let's try another one. 2, oops, and I want to plug in not 3, I want to plug in the new number of 4. 2 times 4 plus 2, is that 10? Yes. And lastly, let's try 5. Let's plug in 5. And plus 2, yes. It does work, I get 12. So since it worked for all of them, I know that this is our rule. And now I need to write it with variables instead of using the numbers. So instead of the numbers that I'm putting in, I'm going to use, remember what I said stood for input? Yes, it is x, okay? And so instead of using all those numbers, I'm going to use 2 times x, and then we had to add 2. Now I only have one variable that I use, so now I need a variable for just the answer. So I'm going to put I can either put the y here, y equals, so the answer is on the left-hand side of the equation, or I can even put it on this side as well. Either way is correct, as long as I have the y by itself, because the y stands for the answer, the output. So that has to be by itself. The rest of it on this side is kind of like the rule that we're going to follow for every number that we plug in. And so I'm going to leave it this way, but you can write it either way in your notes. Okay? Now, what if we have a situation and we need to figure out the relationship between the numbers and figure out what we need to do to them, like what operation we need to do. And then we got to create an equation. Well, here are some steps. The first thing what I would do is I would look for the information that will change, because x's, the numbers that we plug in, those numbers change. We can plug in any number. So we need to figure out what number in the, in the problem that we're working on, what is the thing that can change? And that's always going to be our domain, our x. And so is it, time? Is it months, years, stuff like that that's going to change? Is it dollar amounts that will change? Is it distance? Like miles, feet, stuff like that. Is it measurements, which also could be measured in feet and inches and, stuff like that. So these are just, examples of what things could change. It could be number of people that could change. It could just be a number of items or slash people, things. And so anything that could possibly change. I'm trying to make this small enough so that it will fit. And now let's look at number 2. It says, what number will it change by? So we need to figure out what's the number that's staying the same, that will constantly stay the same. Like in our last problem where we had this 7 times x, well, the 7 stayed the same. In this problem, we had 2 times 2, that stayed the same, plus 2. Plus 2 also stayed the same. So we need to figure out what number or numbers, okay, are going to stay the same. So now, number 3, it says, what is the total? And so we need to figure out, like, the total is going to be all the y's, or the range. And so it is, and I don't want to put change. Okay, so this is our total. And so remember that total can go on the right side or the left side of the equal sign. It doesn't matter. And so we need to look at this. Here's an example of just how things could look. So we could have our variable, the thing that's changing, and then we need to figure out an operation of what it's changing by, and the number of how much it's changing by. And then this is our answer, and we're going to use a variable again. So we're going to have a variable here and a variable there. Now, remember I said you can flip this around and put all of this on the right side, and then the answer on the left side. As long as the answer is by itself, either way it works. So let's look at the first problem. Hamza bought $75 worth of apps each year. Whoa, it's a lot of apps every single year. Write an equation between the amount of apps in years. Okay, so 75 apps per year. So first of all, what is the thing that's changing? Okay, so the thing that's changing is the years. The years, because it's time changes. So the number of years is changing. I could go 1 year, 2 years, 3 years, 4 years, 5 years, That's the thing that's changing at this point. Okay. Then what is the thing that's staying constant? Yes, Hamza is spending $75 every year. So that's staying constant. Okay, so now we need to figure out what do we do with the number of years that's changing and the $75 that stay constant. What operation do we do? Every single year it's $75 every year. What operation would that be? And another way to say it is it's $75 per year. So the word per, what operation does that mean? Add, subtract, multiply, or divide. And here this can help you out too. I basically made a sketch of what the cost would be every single year. So here's 1 year, $75, 2 years, $150, 3 years, $225. How much are they going up by? Yeah, they are going up by 75. So 75, and then remember I said if there's a constant pattern here, then we're going to use that pattern and we're going to put it next to x. So it's 75 per year, and a number next to another number always means multiplication. So we're going to do 75 times years, and they're telling us to use y. We're not going to use x. I'm sorry about that. So we're going to use y for years, and then we need an equal sign because our equation always has an equal sign. And then the other thing is apps. Okay, and it's kind of like our amount, our dollar amount for apps, how much that's going to equal in the end. And so our equation can be written like this, or we can flip it around and write it like this. It does not matter. Either one is correct. Okay, and that's my answer. I wrote an equation for a function and it actually works. I can do 1 time, so I can put 1 in here, and I do 1 times 75 and I get 75. I could put 2 in there. 2 times 75 and I get 150. 3, I put a 3 in there. 3 times 75, I get 225, and that's my answer. The next problem. What if every time Deontay buys a video game for $10, he has to put $2 into his savings account? Write an equation using two variables to show the relationship between the number of video games, G, and C, the total cost, including money he has to put in his savings. So first of all, every time Deontay buys a video game, he spends $10. And what else does he spend? $2, because he spends the $10 and then he takes $2 of what he has and puts it in his savings account, which I love it. It's a great way to save. Okay, good idea. And then, so what's the thing that is changing? Yeah, games. Number of video games is what's the thing that's changing. So we're going to use G as the thing that's changing. And so that means C, since it's total cost, that's going to be our ending amount. Now, here's my question to you. He is spending $10 on the video, and then $2 he puts in his savings. How can I show that? Because, I mean, that is the amount that is constant. Well, one way to show it is I can do 10 plus 2. And I can do 10 for the video game, 2 into savings, and then times the number of games. The other way that I could do this is I could just say, well, I spend $12 every game that I buy, because 10 is for the game and 2 is for savings, and that equals my total cost. And so for your ticket today, what I would like you to do is do the following two problems. The first one is this one about Violet riding a roller coaster. And then the second problem is this problem.